Thanks everyone for coming, and thanks for having me, London Clojurians. This talk is called Basilisp, which is the name of the project, Clojure on the Python VM. So I'll just get started. Just a little bit about me, so you have a little context. I am mostly programming in Python professionally, not Clojure, although I did have a stint many years ago where I was professionally programming in Clojure, which is sort of what brought me to this project and to this idea. Another thing that's sort of maybe a little bit bizarre or unexpected about my background is that I'm not a data scientist, ML or AI expert, or any other sort of scientific user. I know that's probably people who are going to be most interested in this project, particularly given the amount of scientific libraries that are in use in Python, but I am not one of those. So just a little bit of context. I'm happy that people are using it regardless of whether or not that is my background. But let's see. I have been working on this project since about May of 2018, which is probably also close to when this picture was taken. You can see I had a lot less hair at that time. And I am not working on this project in a professional capacity. So maybe a little slow to respond sometimes, but I do see your bug reports and requests and things like that. So cool. Here's just a couple, like a little agenda topics of what I'm going to talk about today. But I'll just move right on then. So what is Basilisp? It is a Clojure compatible Lisp dialect running on Python 3. I typically attempt to support all of the current Python 3 versions. So as of maybe about a week or two ago, that's 3.9 through 3.13, which are all currently supported by the Python Foundation or whatever it's called, I forget. So modern versions typically. Why do I say ish though? That's something that people might be a little confused about. And maybe the most obvious reason is that there are some incompatibilities between Python VM and the JVM that make being 100% compatible pretty difficult. And I guess another point which I like to bring up is that, and probably many of you here agree with me on this, hosted languages do really help us get the best of both worlds. We have the kind of utility of the host language, VM, large library, selection of libraries to choose from, but we also get that hosted language, and in that case, that's Clojure, and that's what brings us all here today. It's super powerful. But yeah, despite all of its blemishes, and I'm sure many of you have your thoughts about Python and the Python ecosystem, it is a robust ecosystem, tons of libraries, tons of things that people use every day for scientific and non-scientific pursuits. So it has a lot to offer. And I don't want to shy away from that. I think that's like a really powerful feature. Basilisp, just in case you did not know, and we'll talk a bit more about this later as well, but it compiles down to Python code at runtime, not ahead of time. And I will talk, I'll give some examples and show you what that means. Let's see. There is support for the nREPL, which a lot of people, especially Clojure people, love. So, and my thanks to this GitHub user. I'm probably going to butcher the name. I think it's Ikapaki, who has pushed that along. Support added to Basilisp, Cider, and Calva. Really awesome. Thank you. Okay, cool. This is a kind of a side project for me, as I mentioned at the top. So saying that I have goals is maybe like a little bit a strange way of putting it, but these are some things that I put front of mind when I'm working on Basilisp. For one, platform agnostic features, I really would like for them to be as close to at parity with Clojure as possible. Something that I really think is important also, and I think I alluded to this earlier, but I'll just say it again, good interoperability with Python and the Python ecosystem. And something else that I think is really important, every project I use that has good documentation is more fun to use than those that do not. So I have tried to really spend a lot of time and effort towards improving the documentation on this project. Almost everything that I'm going to cover in this talk today has some amount of documentation on the read the docs, which I'll link to at the end. So if you want to know more, I would recommend you start there. obviously the source is also open, so please go check that out as well. But yeah, I really put a lot of effort into that, and I hope it shows. So whenever I see projects like this one posted online, Reddit or other places, I see a lot of people asking, why does it exist? And I'll kind of head that off by saying, like, I think that's a terrible question. People should be able to make new things and learn, and just, you don't have to justify yourself. But that being said, I'm going to answer that question a little bit. First, though, I do want to show probably some things that you are all quite familiar with. These old XKCDs, which kind of perfectly align with this project. There's the beauty of Lisp, but also the power of Python. I'm sure you probably all have seen those, but seem too perfect to leave out. Okay, the actual why. Yeah, when I started, I'd only been working as an engineer for a couple of years. Something that I thought was super interesting and cool was compilers. And everybody's first project is to make a toy Lisp, but I tried to make a real Lisp. I didn't invent the Lisp. Obviously, that's rich, but having a good example to build off of is so much easier and more helpful. So just to see if I could, yeah. I think this is something that probably brings us all together here, but like Clojure absolutely changed the way that I think about programming and solving problems generally. So it just seemed like the perfect example. I love Python. I love that it has such a rich ecosystem, as I've mentioned before, so many great libraries and tools. But sometimes writing a loop is just a real pain in the butt. So when I start thinking about like all the wonderful functional tools that Clojure offers, and tons of other things as well, I just thought, why those two things might be better together. So that was definitely something that was top of mind for me. And Clojure already had implementations for JVM, Common Language Runtime, and JavaScript. Why not Python? It's one of the top 5 languages in the entire world. Tons of scientific users. Like myself, there are non-scientific users making apps and all kinds of other things. So it seemed like a good fit. And, just for my own ego here, the vain hope that after working on something like this for so long, that somebody would invite me to give a talk. So once again, thanks for inviting me. Cool. I'm going to talk a little bit about now the interoperability with Python. And I'll just start here with types. So, just to start off, the really basic ones, the scalar types in Basilisp, integers, floats, strings, etc. Those are all just your standard Python host types. There are a couple of differences, which are sometimes a little easier. If you're familiar with big ints in Clojure, suffixing with an n, that's not really necessary in Python because all Python integers are already arbitrary precision. Floats are the same. Decimals, big decimal in Clojure is a decimal in Python. Ratios, Python has a great fraction type for that, so we use that. Strings are the same. We don't have characters in Python, so that's just a single character string. Your booleans and nil is none. Those are pretty basic. There are a couple of extensions that I added just so that people could really use the full power of the Python interpreter. Complex numbers, I don't use them, but I'm sure they're quite valuable, which is why they're in there. So just suffix your number with a J, and you got a complex. And another one that shows up a lot in Python code is bytes. So you can create a byte string easily with this B reader, data reader, which is built in. I'm not showing them here because they won't be terribly interesting. They look and operate exactly the same as in Clojure, but the full complement of persistent data structures based on the persistent library, and the immutables library, excuse me. And these are both actually based on Clojure themselves, so the semantics are quite similar. I will note, I did just say every persistent data type, but in fact, sorted sets and a couple of other ones are actually not included right now. And then another thing that people probably will find useful, particularly as they're interoperating with Python, is actually creating the Python collection types themselves. A lot of Python code will actually expect those, or do something that I know we all hate, like mutating the object. So you can create those easily with just the PyData reader as well. Let's see, another one that you'll end up using a lot. For those who are not familiar with Python, there's about maybe 40 or 50 built-in functions. These are typically available in a module without any sort of namespace reference or importing required. In Basilisp, they're available using this Python pseudo namespace. Don't have to import that either. It's always available. So here's a couple examples. I hope you can see that all right. Just creating a bare object. It's not a terribly interesting thing to do, but you can do it. Or maybe a slightly more useful thing down here, using the Python int constructor for parsing an integer from a string. This is kind of a meaningless example too, but just as a note, you can elide that prefix as well if you'd like. But these are often useful if you're interoperating with Python code directly, or perhaps writing something sort of at the boundary of Basilisp and Python. Okay, talk a little bit about dealing with objects. There are some looser semantics here than might be required in Clojure. Constructing a Python object works pretty similarly as it does to create a Java object in Clojure. But things like you don't need to use the new keyword ever. Python does not have one, and creating an object looks like a function call. So, sorry, I think this one might be a little small here, but you can see just creating a pathlib path, which is just an object that represents a kind of path, doesn't have to be real. There is a compatibility syntax here for creating a new object, or if you happen to be using this code already, although there is no pathlib in Java, so you probably wouldn't be doing that. Pretty straightforward. Let's see. And then method calls and property accesses work pretty much exactly the same, with one perhaps minor difference. In Python, the actual Python code is typically snake case, unless you're dealing with something that's like a little bit older before people sort of standardized on that. So you'll see here, there's the is absolute method on a path, and you can actually write that with kebab case if you like. You can also write it in snake case. I like to use the kebab case. I think it reads a little bit better, and it's also easier to type. So that's automatically written, munged down to the correct name. And I don't think people use property access in Clojure, though I might be mistaken. But it's quite common in Python code, so that can be done with the dot hyphen form here. Calling functions and method calls, yeah. So if you're just calling a basic positional argument only function written in Python, that will look exactly the same way and look and work exactly the same way as calling a Clojure function, which is awesome and very easy. But one thing that Python has that does not have any equivalent in Java or the JVM ecosystem are keyword arguments. So I sort of had to concoct a way of dealing with that. There was no kind of prior art, at least not that I was aware of, because it's sort of a syntactic element in the Python side. So the way that you do that, here's an example of a Python built-in function, open, for opening a file. And it typically takes keyword arguments for the file encoding, the mode, writer or reader, other things like how you want to treat encoding errors and things like that. So you do sort of need this syntax. So the way that works in Basilisp is you see these little 2-star characters here, and that tells the compiler anything after that is going to be keyword arguments, which you can specify exactly the same way that you would do with Clojure keyword arguments, just a pair of key value pairs, one after the other. So the way that works under the hood, you can see the Python code that gets generated there. Sorry, it's a little hard to read because it's a comment, but those are detected, like I said, at compile time. Keywords are, again, going to be munged down, so they are safe Python identifiers, because this is an identifier in the Python code. This double star is consumed by the compiler. It's not like going to be resolved or anything like that, so no problem there. And then I have an example here. This works the same on functions or methods. So here's an example of calling this method the split method on a string. Works just the same. So that's something that comes up fairly frequently when you're dealing with Python code. So useful to have that. All right. Importing modules. This is another big one, and it's pretty similar to requiring a namespace in Clojure, and not at all similar to importing classes in Java, which, if you're familiar with Python, probably you already understand. It works very similarly in Basilisp. You just import the name, use the import macro to import the name, and then you can directly refer to anything in that module, just exactly the same way that you might do with a namespace. You can even give it an alias, which is another common thing that you can do in Python code as well. Things that aren't currently supported, I don't really see any reason that we couldn't eventually do them, but they're not currently supported. There's no support for the import star syntax, which might be in Clojure would be like refer all. Nor can you refer individual names from a module. So we'll get to that eventually. All right, get a little grab bag of a couple more things that might be interesting to folks. Something that I think you occasionally need in Clojure JVM, as well as a few corner cases in ClojureScript, are type hints. They are never needed in Basilisp. You can add them though, and they will get thrown all the way down to the Python AST, but they're not needed. The compiler is able to figure out in general what objects are, and it does not require any type hints. Cool. This is a huge one. I'm not sure if anyone here has actually used Python, but a common problem is that there are significant differences between Python versions. This is happening less and less frequently as they've sort of gotten, fixed a lot of the blemishes from the early period of Python 3, which I'm sure you all probably remember reading at that time how people were so frustrated about all the changes. But there are often minor and major differences between versions. And so one thing that you typically do in Python code is just conditionally define different functions based on the version of Python that you're running in, which, as long as the syntax hasn't changed, is legal to do. But it's kind of ugly, and it means that you just have like this big if statement somewhere at the top of your file. So what I have done, in addition to just the classic, reader conditional for Basilisp code for eventual CLG support, there's all these different version reader conditionals which are available. So for if you want to get greater than or equal to 3.10, you can add this lpy 310 plus, less than or equal to 10, or maybe specifically if you just want to lock to a specific version. And then another one that comes up not super frequently, particularly if you're not dealing with the host system, but Python's various libraries in the standard library are not quite as abstract as sometimes you see in like the JVM standard libraries. So you may actually have to use different APIs for various OS-related functions or dealing with I/O. So there are also some nice reader conditionals for dealing with Windows, Darwin, Linux, etc. One thing that I mentioned up at the top, and I think I just want to say again, I did want to make sure that this was a tool that was really useful and well integrated with Python. So it is definitely possible to import Basilisp code in Python code and call it, so long as the signatures, I guess there's no signature mismatch really. So I don't know how often this would be necessary, but it is not, there's no reason that you shouldn't be able to do this. So that's fantastic, I think. A couple of other things that may come up here and there, particularly with interoperability. It is possible to define Basilisp functions which accept keyword arguments, Python keyword arguments, that is, and either converts them into the Basilisp style, like Clojure style keyword arguments, or collects them into a map. This is detailed a little bit more in the documentation. I wouldn't recommend doing this, but you might need to do it for maybe passing a callback or something like that. I've seen that before. And then really kind of at the edge of support here, but something that was maybe useful occasionally, is it is actually possible to define Python async and await or async functions and use await expressions within those, as well as creating Python generators with the yield expression. Again, probably not likely to be used very often, but may occasionally be useful or necessary depending on the interoperate or the code that you're interoperating with. All right. I'll be honest with you, I don't know how interested everyone is going to be in this, but it's something that I've worked in a lot, and so I thought I might throw a little bit in here about this. I do remember seeing, I'm not sure if you all are familiar, there's another Lisp dialect which compiles down to Python code called Hi, and very recently it hit the 1.0 milestone. And I remember seeing a lot of comments online where people were like, how does this work? What is it doing under the hood? So I thought I would address that a little bit here. There's more documentation on this on the Basilisp project documentation as well if you're interested, but I'll touch on it a little bit here. So Basilisp works pretty similar to Clojure JVM, doing form at a time compilation, which does mean certain things, like it's not really possible to use like just a require or an import within a form and then immediately call, like reference something from that. You could use require and resolve or something like that, but the compiler is working in terms of like blocks of code, top level blocks or forms. I'm thinking of Python code instead of Clojure. And it is not like Clojure script. There is no separation of macro namespaces. So you can define a macro and use it right away. The compiler is a phase compile per form, like I said. So we'll read the form from the source document, analyze it, and produce an internal AST, which is based on the very great library tools.analyzer, in case any of you are familiar with that. Super helpful starting point for writing a Clojure implementation. That ultimately generates Python AST nodes. If you are not familiar, Python actually has a standard library module called AST, where you can construct or manipulate its AST nodes directly, which is awesome. Obviously, Python being a white space limited language means that writing that code as a string would be super annoying to deal with all the different levels of indentation. So having the AST library directly obviates the need for that. And the other thing that's great about that is that conformant Python implementations will have an AST module, and I won't need to worry about bytecode, which the CPython bytecode is not stable, and other languages or other implementations, such as PyPy, for instance, don't even use it, obviously, because it's not stable, but for other reasons as well. So this is great. This means it's fairly easy to get support for other Python implementations. One that I'm hoping to eventually get as well is GrailPy, which is continually being developed on as well. Looking forward to that. And then eventually that AST is compiled directly using Python's built-in compile function, which is, if you didn't know, that is just one of those built-in functions, and it can take either a string or an AST node and compile it right away, which is very helpful. The other features that we have here, there's and this is sort of this importer that I'm talking about based on Python's import lib, facilitates importing Basilisp code, and that is basically how we are also able to support importing and using Basilisp code directly from Python. And one of the other things about that is that, that means that there's kind of a one-to-one mapping between a Basilisp namespace and a Python module, which is how Python organizes its code. Essentially when you define a function or a class or any other thing, just a value, it has to live somewhere in memory. So Python uses modules for that. So the namespace is backed by a module. Let's see. Great. So some other sort of useful things, particularly at this early stage of the project's lifecycle. It is possible to inspect the generated Python code. You can use this print generated Python in any namespace. I'll just say it's pretty messy, and I actually have an example of it later in case people are interested, but it's not generated with any intent to be checked in anywhere or read by humans. So yeah, it's mostly just useful for debugging. Maybe something is not making sense to you. It can sometimes be helpful to look at the Python code to see like what's what's this thing doing. Yeah, the compiler does a number of optimizations. I'm sure that it's probably shared by many people here. Python has a reputation for being slow unless you're kind of using one of those libraries that's written in Rust or C or something like that. But the Basilisp compiler is it's making its best attempt to generate code that's pretty close to raw Python code that you would write or similar enough. And so there's a number of optimizations that are done under the hood to help with that. So I will say that, vars are reified as they would be in Clojure JVM, but the values are typically directly linked by default so that you don't have to go through the var to get to it. This is overridable per var, or you can set a command line argument if you just don't want to do that. You want to have the full sort of dynamism of Clojure. Inlining, library functions are typically inlined as available. So if that library function is maybe just calling a method directly, or using or delegating to like a runtime function, runtime being the Basilisp runtime, that is, those are often inline, so you don't have to pay the extra cost of just like calling a function that just calls another function. And then things like the standard Python operators are typically optimized as well. If you're not familiar, there's kind of an ongoing project in the CPython community to improve the speed of many different operations. The way they're typically doing that is developing custom bytecode implementations for specific operations. So being able to give the Python interpreter, the compiler that we rely on under the hood there, the most representative code that you're actually writing, that means that we can also take advantage of that on our side. And I don't think I actually mentioned this in the importer, but one of the other side benefits of using the import lib, Python import lib, is compiled bytecode is cached, just the same way it is with Python, which means that an initial require may be slow, but any subsequent accesses, even across process indications, are fast. The cache is, of course, invalidated if you change a file, but if you were to load up the REPL, your core library, Basilisp core, will take a little while on your first load, but the second one should be lightning fast, and the caching is how we do that. So that's a great feature, and really excited about that. Talk a little bit about some challenges with writing this compiler. Yeah. So Python is a language of statements and expressions. Obviously, in Clojure, everything is an expression. So that one was fairly easy to resolve, but it is something that you have to be mindful of. The Basilisp compiler just will admit any required statements, that be it a class or function definition, and then just always returns an expression. That's fairly easy, but you do have to, if you're developing on it, you have to be mindful of that fact. Like you need to return something. A bigger one here that maybe some of you are already thinking about is that there are no multi-arity functions or methods in Python. And I'm not going to say that I got the right solution here, but I'm going to tell you what the solution that we are using is, which is that Basilisp compiler generates a function which dispatches to the correct arity based on the number of arguments, which works pretty well. Typically, Python actually kind of groups all the positional arguments into a tuple before it sends it to a function, so you can get that length fairly quickly. But it is an extra step and something that has to be generated specifically to deal with multi-arity functions. Another one, Python has a very loose definition of falsiness because any object can customize its own falsiness by overriding this bool dunder or magic method in Python, which is a lot more flexible, but also kind of frustrating when you're dealing with a mapping to a pretty simple language with a simple heuristic like closures, where false and nil are the only falses. And actually, like I said, I'm going to show a little example of some generated code later, and you might see what I mean when I say that. And this is possibly the biggest one that is kind of constantly an issue for me and for people who are probably going to be working in this language. Python I mean, it's not really a language of interfaces in the same way that Java, JVM adjacent languages are. Certainly, there's the concept of duck types and collections.abc for if you want to sort of emulate a collection type, and a few other things, like it's possible to emulate numeric types and things like that. But outside of that standard library, and even within parts of it, people don't really create interfaces, and if they do, they're not strictly enforced. So this makes a lot of the features sort of at the kind of host, the periphery of the host, interop side of Clojure a little bit challenging to deal with. I'm thinking of things like def record, def type, and reify, things like that, because we don't always have an interface in a way that you might expect to have in Clojure. Basilisk uses Python's ABC metaclass type. ABC stands for abstract base class. And that is the intended interface type. And any subclass of that type we treat as an interface. But people don't often use that. It's certainly legal in Python to just create an object with some methods and say, like, you can subclass this now. Like that's the interface. And that happens a lot. An example that has come up inside of the Basilisk standard library is Python's own I/O module, which is obviously pretty important. You need to be able to input and output from our function or from our code. They define an entire hierarchy of writers and readers, and none of them are considered ABCs. And in fact, there are methods that are not required or required but not written or not included. So it's hard for the compiler to figure out if something is an interface. If you want to dive a little bit deeper on this and you're ending up writing something, reified or something like that, def type, there are some escape hatches in the compiler, or rather that you can use to sort of tell it what a expected interface is. And that is unfortunate, but check out the documentation if you want to know a little bit more. But it is a huge challenge, and one that you're likely to run into if you're ever trying to define one of those types. Yeah, so it's a little bit challenging. We already got to touch on that. All right, I'm going to show a little example here. This is our implementation of RE matches, which hopefully similar to the one that's actually in Clojure core, but I'm not sure. Pretty basic. I don't expect you all to remember all this, but just a couple of simple structures that I thought might be helpful to sort of see what happens under the hood. So this is what gets generated, and it's super messy, of course, because it's compiled code that I told you is hard to read. But you'll see there's some annoying things here, like these numeric suffixes, which are just artifacts of compilation. But it looks pretty similar if you kind of can look away from those, those suffixes. We're delegating to the full match function of the RE module. I mentioned the falsiness issue. So the compiler actually reverses the if branches to check for none and false specifically. Because if you aren't familiar, an annoying thing in Python is that bool is a subtype of int. So you have to sort of check for the identity for false. It's a little bit frustrating. Yeah, and then the sort of meat of that function is fairly similar as well. Obviously, a little bit obscured here, but looks pretty similar. And I'll just show you, if I were to write this by hand, looks like that. Pretty similar. Obviously, don't have it. There's some redundant assignments and things like that. But otherwise, it's a pretty clean match between what we wrote and what got generated. So cool. Now, the last thing I want to touch on a little bit here, because it's something that I think comes up a lot in the Python space, is sort of dependencies and environment management. I'm sure I will be preaching to the choir here when I say Python is just notorious for its confusing and difficult environment setup. I've worked professionally in it for a long time, so I'm fairly familiar with how to do this how to set up an environment, get dependencies, all that sort of thing. But I do totally understand why people think what they do about that. It's very justified opinion. I'm not going to resolve this for anyone here, but if it helps at all, the Python virtual environment, which again is a very annoying thing to set up, but it's a little bit of it's like a class path in some sense. Just it involves both shell variables and specific locations in the file system where dependencies are put. That's just a little bit different because and I think if you're using like a Maven type of tool or a tool using Maven dependencies, there's like a kind of global registry where all the different versions of different dependencies are placed. And that's just not how it works in Python, unfortunately. But totally understand the frustration there. One thing that can kind of help a little bit is using Python. This is not about your environment, but it's certainly something that I would recommend if you're going to be using Basilisp at all. This helps you manage at least which versions of Python you're installing. Super helpful tool. It's based on this tool RVN, and if you are a Clojure person, you may be using something like SDKman to control the version of the JVM that you're using. So it's a pretty similar tool to that, and it can also install Anaconda or some of the other distributions PyPy of Python besides just CPython. So something that's pretty useful to think about there. One thing I'll say here is, and this is to everyone's great disappointment, but there is no project management tool right now for Basilisp. I'm very sorry about that. It's definitely something that I feel that is frustrating to a lot of people, myself included. Time is being what it is somewhat limited, so I haven't really had time to work on this at all. I would recommend using some of the Python ecosystem tools. There are some newer ones that are a little bit better and less error prone or difficult to use than just classic pip. This project is using Poetry. There's Hatch, PDM, UV is a new up and comer that people seem to like a lot. So that might be something to look into for now. And I called out this person earlier, but I'll do it again. Ikipaki, sorry, I keep mispronouncing that, I'm sure, has created and published several libraries already using one of these tools, I think. And these also may be of interest to those of you who are in the scientific space and are sort of looking to use Basilisp. So both serves as an example for how to do something like this, at least with the tooling that exists now, and might be useful just in general for your exploration or usage for whatever task you want. And here's another one that gets asked a lot, and I'll just say, sorry, there is no support for Clojure dependencies yet. It is not any technical reason. I just simply have not gotten around to it. So that's something that's planned, and I'm aware of that deficiency. Cool. Let me talk about just a few things that I'm thinking about for the future. This is not in order, it's not comprehensive, but just something, some things that are kind of next up, I guess. I want to complete the Clojure core library implementation. A lot of stuff is done. It should be very, very usable, but there are some sort of like other libraries inside of the Clojure standard library that are not included. For instance, pprint. I write proxies. I'm not sure how important that is to people, but it is useful for pprint specifically, which is maybe why they're not done. Things like datafy, nav. There's many new things in Clojure 1.12, which I haven't really had a chance to dive into yet, but I think probably they're not done and certainly need to be worked on. Ongoing work here, but I'll just say it, obviously fixing bugs and incompatibilities. There's often people get in to using Basilisp and they realize that like, oh, this is not exactly the same as it is in Clojure. There may be a reason for that. I don't always know, but definitely, if you see something, file a ticket. Definitely helpful for me. You can also show how it works in Clojure. So I can sort of compare the two and understand why there might be a difference. Yeah, not currently able to load CLJC files. I don't think this is like a big lift or anything. It just isn't something that I've worked on yet. I imagine it'll go together with actually loading up Python or Clojure dependencies directly. This I mentioned as well, project and dependency tooling obviously would be huge. Would love to get to it. Something like Lineagen or tool steps or what have you. And this is maybe just more of a vanity thing. I'm not even sure how useful this would be, but something I thought might be fun is just replacing some of this lower parts of the Python Basilisp runtime with native components. There are a few things, if you were to profile, that are really slow. Would love to sort of replace those with something native. Yeah. Awesome. And then I just got some, like references here and other things that I've mentioned throughout the documentation or throughout this presentation, excuse me. Link to the GitHub, link to the documentation, which I really, if you are curious about anything I've talked about in this presentation, I would super recommend you go through that. I have lots of documentation about interoperability, how the compiler works, full set of API documentation, which is automatically generated on every commit. So a good place to start for anything like that. There's also on the GitHub, I didn't link to it directly, but it's in the repo. There's a discussion, which you may like, I don't know. There's also the Clojurians channel, Basilisp. I'm not so much of a Slack guy myself. I like the discussion. It also isn't ephemeral, but people have different interests, so definitely use whichever one or both of those that you're interested in. And then I just linked some other things that I referenced here in case people are interested, may or may not be. Yeah, that's it. You guys enjoy it.